Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This will hopefully be our last video on implementing our binary search tree. We need to finish off our remove method and then test it. So in the last video we started writing the remove method and we said we're going to break it into two parts. We have one recursive function which finds the node we're removing or doesn't find it, in which case it just returns null. And it does this recursively so it relinks everything as it comes back up because that generally simplifies the logic. And then it relies on another function called RemoveMax, which is supposed to remove the maximum node to the left side and it's supposed to give us back three things: the key and the value from that node, as well as the node value that we should link into on the left. So we'll see if this is sufficient. I'm actually we'll see if we need to write a special case for this situation here, where the thing on the left has no children. That would actually be simple enough to do. We just pull that up in, and it's possible that dealing with that in RemoveMax could complicate our logic sufficiently, but might not. We'll see. Okay, so what does RemoveMax do? Well, it gets hold of a node in, and it should continue walking down the right until it finds the thing that belongs down there. So if there is a right child, we need to go there. And if there isn't a right child, then this is the max. So if in.right is equal to null, we're going to do one thing, else we're going to do something else. So what do we do if, and in case you're wondering, all of these errors are because we promised we'd return this 3 tuple and we haven't returned anything yet. So those will go away as soon as we have appropriate return values. So I think the easier case to write is the case where there is not, or where there is a right child, in which case I want to set in.right equal to, I'll do a node, where once again we're going to do our recursive call here. So val, I'll do the kv node equals, equals remove max of in.right. So we go down to the right, we link back up that node, and then we're going to return k comma v comma this current node, the in value, not the one that was returned here. That's supposed to be the right child for this node. We're supposed to return ourselves because we weren't removed, so we're just going to link back in. In the case where there is no right child, that means that we have found the node that is the largest, and what we need to do is return, is this actually going to be that simple? I believe it is. We need to return in.key, in.value, and in.left. Okay. So let's talk about this for a second. So okay, let's take the situation where we're removing the 5, and we call RemoveMax on the 3. Well, 3 has a right child, so the first time we invoke this version here, which calls RemoveMax on the 4. 4 does not have a right child. So what does it do? Well, it remembers the 4 and whatever value is associated with the 4, returns both of those as well as the left child, which is null. Okay. That left child gets passed back up to here, and on the call stack, that happens to be waiting, so that gets returned back up to here, so we get the 4, whatever data was associated with the 4, and a null into here, into the node that had the 3 in it. So now the 3's right is going to be set to null, and that's exactly what we want. After doing this, the 4 is going to, this node is going to go away, so 3's right should be set to null. And then we return the key and value, once again associated with the 4, as well as the 3 node. So it returns this node here along with the data that was associated with that, and that gets passed all the way back up to this call location. So then the 5's left is set to be 3, which is once again what we want. This should still continue pointing to that node. That's all fine. And then the value, the key 4 and the value for 4 are stored into the node that has the 5. So this is now a null pointer here, and whatever data had been down here for the 4 is now at the 5, and we're done and everything's happy. So that's the situation where we're deleting a 5. What about the situation where we're deleting the 2? We want to make sure that this kind of edge case, or where we're deleting the 3, because the 2 has no right children, I want to make sure that this edge case makes sense. And possibly, even if there were a 1 here, we still want to make sure that it's happy, though these will be 2 slightly different situations. So what happens in that situation? Well, we'd call RemoveMax and we'd pass it the 2 node. So that comes down here, we get the 2 node. The 2 node has no write, so it immediately returns back with the key, the value, and its left. Right now its left is null. If there were a 1, its left would be the 1. So we return back the data for the 2 and this pointer right over here. That goes back up, and we wind up resetting on this node, giving it a left pointer, which was equal to what this returned, so in this case null, that's what we want, and the 2's data goes into there. So that seems reasonable to me. So at least tracing through this appears to be something that would work. So now we need to test this. Okay, so copy, we're going to say remove 5, and then I'm going to write some others. So how do we do this? There are different ways that we could test this. Copy, paste. So after adding all of these, I want to do map minus equals 5, because that's, whoops, wrong function. I need to go down to this one. Okay. So map minus equals 5, and we can then check. Now it should not find anything when we call get. Actually, for the 5, we should have a check here. Let's make sure this returns none. We technically haven't done that check previously, so that was a deficiency in our testing. Of course, we kind of knew that our tests weren't sufficient. But we want to make sure that everything that's in here previously is still found, and the 5 is not found. It would also be nice if this iterator comes back and it gives us everything 2 through 8 with the exception of 5. So I want to filter for underscore not equal to 5, and then make sure that those are all in there. And we run the tests, and they all pass. Because we talked about this being something of a special case, let's also do the remove 3, and I will do a remove 2. So when I do a remove 3, this case turns to none, and this is sum 5, and I want to filter off 3. And for remove 2, or remove 4, really doesn't matter. 4, the 4 goes to none, sum 5, and filter not equal to 4. So given that small tree, well, those would have been the things we want. Num, but was sum 4 for remove 4. Oh, well, that would be a problem, wouldn't it? Let's make sure that our test is written correctly. we add in all of our values, and then we remove the 4. And this says that when we called get on 4, we're still returning something. Definitely problematic. Wonder if that would happen when we return the 2. So, what happens in this situation where we remove the 4? We trace through the situation with the 2, and in fact, let's go ahead and let's write the test for that, just to make sure that remove 2 works. Copy, paste, remove 2, because we traced through that one and that one seemed to be fine. But tracing through things by hand is not quite as good as this says failures 2. So we have a failure in remove 2 and in remove 3. And there again. Okay, so something is happening where even though I said to remove the 2, we are still finding the 2. So what happens in that situation? Well, the 2 should be one of our special cases up here where this doesn't even go down to the RemoveMax. This is supposed to be that because the 2 and the 4 both have a left child that is null, so they should trigger this case right here, and then they should return in.right, which should be linked in with the parent. You know, now that I'm looking at this, we have, here's the problem right here. I am over aggressively returning in for everything, and now we have errors because that shouldn't happen. Okay, so the in.right and the in.left are return values. I want to keep those. This one should return in, and this one should return in, and this one should return in, but I had it returning in down here, which was covering a few too many cases. So we run our tests again. Now remove 4 passed, but remove 2 didn't. And that's because I forgot to change the 4 to the 2 in the filter. So it's a good thing that that crashed. And okay, now the test is doing the correct thing. It works. So just to make it clear, that last bug that we had is because this recursive method has to return the right node to link back in. The way Scala works, remember the last expression that you have is what you return. So the in.right and the in.left here only get returned if there's nothing else that follows it after this if right here. So if we go down and look what lines up, I had the in down there, and while in is what I want to return from 3 of the branches here, I don't want to return it from these 2. So that completes our BST map. You could feel free to write more significant tests of that. We'll look briefly in the next video, or talk briefly about how we could make an immutable version of this instead of the mutable version and what that would look like.